Welcome to MDIDS-GT, the multidisciplinary integrated design system for gas turbines. In this instructional video, we will review the steps to create the turbofan fan stage Meridional splitter that separates the core and bypass flows. Let us start by opening our previous turbofan design, initialize the preliminary performance using step 1, and verify that we have a proper solution. Let us open step 2, design point analysis, and navigate to the fan stage. What we have here is a fan stage composed of a rotor, a core stator, a bypass stator, also known as a split stator, and a bypass strut. We would like to add a Meridional splitter. To do so, click on the Meridional splitter menu button to open the splitter design window. What we see is a blank list for the splitter coordinates, which stems from the preliminary cross-section setup process. If the splitter was previously designed, we should see a list of coordinates. Let us add 5 rows by selecting the first row and right-clicking to access the Add and Delete options. As mentioned in the design window, the Meridional splitter is designed in a counterclockwise orientation, starting from the bypass stator and ending at the core stator. The first point should be defined to be close to the bypass stator hub corner point. The last point should coincide to the core stator tip corner point. The remaining 3 points should define approximately the splitter nose. Select the Draw Meridional Splitter option and then the Construction Points option. Click on the red check mark to accept the changes. In doing so, MDIDS-GT will now draw the Meridional splitter in the stage window and in the main window with the points highlighted as red circles. To align the splitter endpoints to the airfoil corner points, just click on the Update Ends button. You may now improve the Meridional splitter geometry by adding, deleting, and modifying the list of coordinates. It is strongly suggested to not delete the first or last coordinates, since these points are used to align to the airfoil corner points. In the next video, we will use MDIDS-GT to create the input files for an ANSYS TurboGrid and CFX-CFD simulation and analysis.